Welcome everyone to this second episode on the discussion that we're continuously having on scalable modeling. Today we have here Simo Roikonen
Hello.
and myself, Jose Hidalgo. As you know, Simo is the one that has proposed scalable modeling as an approach towards a more towards a system that is ready for growth. And myself, I'm just a student of scalable modeling. Um, And how do we define a growth system in the scalable model approach? As we discussed in the previous episode, a growth system is one that is able to scale without a complete rewrite. It is able to implement or improve resilience if needed, and it is evolve. It evolves as the domain evolves over time. The components that we discussed in the previous episode, the components that make scalable modeling are state, policy, command, and query, and of course that fifth element that is added into the scalable modeling, which is the events. Simo, can you talk to us about this again, like a brief refreshment of what is this, why, what, and how approach that scalable modeling uses to provide solutions?
Yeah, definitely. Yeah, so let's have a bit of a recap to the previous episode to get back into the context. The context is always important. So I guess the good way to start is to go through this picture briefly, which is the kind of the basic blueprint for scalable modeling. It tries to define the rules between these components, and it's kind of a map that guides you when you are doing the scalable modeling. So on the left-hand corner, we have these basic elements. We have these modeling necessities, which we need when we are doing the modeling sessions. And we have the primitives, the commands, events, and queries. And we have the outcomes, command response, state projection, and query response. And we always have also the command response in this approach. It doesn't return much information, but it gives back the validation errors, and it kind of tells if the command was accepted. On the center here, we have the set of components, and they're kind of how we can make them work together. So when the user, the actor, sends a command, it can optionally be handled by this policy type called gatekeeper, which we will be going through later. And then in the internal core of this system, the command is handled by command handler against the state of the system, and it will emit private events which are updating the state. Then there is the tailored consistency, so we can basically in the implementation define which type of consistency do we use on this side. But on the right-hand side, there is usually the eventual consistency in place when we are doing queries to the state. And we have the query handler there. And the data aggregator is also an optional element to kind of collect data from multiple sources through multiple queries and map them together to a query response. We have private events, which are services internal, and we have public events, which are being published outside of the service. We also can define consistency boundaries for the system, and there are external systems at play. And the arrows that we have here, the red arrow is something that we need to do cautiously. For example, when we are getting a command and need to validate it against a state which is not within the strong consistency boundary, there's always a risk of handling stale data. So that's why this arrow is red. And the same goes in the query handler. And especially if we are, this red arrow means that if we are accessing a state from stronger consistency area, that may cause bottlenecks for the system. So we need to be careful when we are doing queries to a stronger consistency parts of the system that can give us limitations, make limitations to scale the system. But of course, when we are dealing with events, we can do duplicate states to the query side and ease this problem. But it's just good to take into account. And the event handler also can consult queries, but it's the same stale data challenge that needs to be addressed in here. But yeah, that's a kind of getting into context. So the scalable modeling is about creating a path from why to how. So why the software is needed and how to implement it. And the scalable modeling addresses how to create the what, the conceptual model that we can collaborate with, that it acts as a kind of a discussion base, a graphical picture of the system to be built that we can iterate and discuss about with the developers and the domain experts, with the designers and all stakeholders. And that's the thing that we are now today demonstrating, how to build this conceptual model, how to help the people align and discuss efficiently. And then this is kind of the simplification of the previous. So this is the toolbox that we start using when we implement the conceptual model. So we will go through these different types of policies today, except the data aggregator. But the data aggregator is basically just a policy that, like mentioned earlier, fetches data from multiple queries and aggregates that together.
Thank you so much for that. Yeah, at the beginning, it seems a bit scary when we look at all these different pieces all connected and trying to describe a mechanism that is supposed to help us improve our systems. It actually looks quite complicated. Now, the use case that we have chosen to discuss today is regarding mostly to the season that we are in today. In this case scenario, Santa has contacted me, and he has stated his desire to upgrade, or rather digitalize, his current system. As you all know, Santa gets to receive the request and the wishes of thousands of lucky kids and unlucky kids if you're a naughty kid, to for gifts or any sort of wish that he can provide. However, this system, it can be quite complex, right? There's many pieces involved. Among them, you have the building of the toy or the wish. You have the who decides or what makes a child to be naughty or to not be naughty, to be a good kid. And then we also have this tracking of the wish, whether this wish has been fulfilled, like if the gift has been delivered. Or also sometimes, as it might be common in today's society, maybe the kid changes his mind on what he wished for this Christmas. So, how do you think, Asimo, we can solve this issue for Santa? At least the more top level part, which is the management of the wishes. Uh, right now he's everything that is being done through paper and by hand. So the little elves are quite busy. I'm sure they want to take a few of the workload off their hands, and I'm sure that a properly developed system can help them with that.
Yeah, yeah, I can kind of feel the problem that there's really like a huge amount of wishes to be handled, and if it's all done by paper, it's must be a lot of work. Uh, so yeah, so how to start solving this problem with scalable modeling? Well, first of all, I think that the scalability is really needed in this in this context of managing millions of wishes. So that's a good solid choice to start with scalable modeling. We can start taking this solution when we get there. We can take it into use into smaller context, maybe in some small country like Finland case, for example, and then scale gradually if the solution is really addressing the need. So we should not start by implementing a huge super scalable system from the scratch early on, but let's just model it so that we can scale it if it becomes successful. And that's what scalable modeling is all about. And it starts by addressing the why, just like in the picture that we have shown. So we always start from really understanding the why as well as we can, and then jumping into the what part. So then we will start mapping the landscape of the problem space. And usually when we are mapping the problem space, that is maybe revealing more reasons, more whys. So we iterate between the why and what for a while. But basically now, just like Jose mentioned, the main problems are that there's a huge volume of wishes. We need to make the lives of the elves a bit easier, get them time to do a bit of holidays as well sometimes, and also the trend that the nowadays children hope they wish something maybe in the November
Change their
time
mind.
frame, and then they change their mind, which is
Yeah,
causing wasted presents, and we want to also reduce the waste. So those are the main problems that we are first starting to address. Yes, and how does it start? Well, there are few of these systems that Santa already has. So this is the normal case when we are starting to implement a system for our customer, that we don't start from the scratch. There always exists some systems, and because of course the time limitation of this podcast, we try to keep it as simple as possible. But we want to add this spice of systems, external systems, also into the exercise. So there are two different systems. The can you actually explain these systems, Jose?
definitely. So the current system that they have right now is this like I guess like a sort of magical tagging that takes place whenever a kid submits a wish. There's a sort of like a set of policies already in place that they tag whether the kid is a naughty kid, whether he has behaved good, and whether he deserves to have his wish fulfilled. And the other one is also the presence logistic, the manufacturing of the present or the wish, the status of how if the wish has what is the percentage of this wish for being complete. Once the wish is completed, it's been sent to the kid, if it has been delivered or not, or those sort of things that have already been taken care of. So we are right now just need to focus on the above part, the wish management part, the fulfillment of it, and from when the moment the kid makes the wish to the moment he receives. So the wish is fulfilled.
Yeah, exactly. Yes. And the to simplify these systems, we are basically only interested, at least in this point, about this event when the child is added to a naughty list, and we are interested about when the presents have been delivered, so that we basically know when the wish is fulfilled. And we want to do few commands also potentially to these systems. So we may want to report at least some systems want to report a naughty child. Uh, we can we must be able to order presents and cancel orders. Those are basically the integration points that we are interested about in this early stage in our modeling. So this is kind of setting the landscape that we need to also take into account when we do the modeling. All right, and let's then start from the very beginning. So this is the starting point after understanding the why. So now we are starting to build the what part. And we have already these two events here, which come from these external systems. So child added to naughty list, which is an external event, and present delivered, which is also an external event, but I added those into the timeline as an internal event for now, and let's see what we will do with those events when we do the planning. But they are there because we know that we can get those from the external systems. And the idea how to start is to just by following the event storming way of work, we start from the events. We start from a temporal time-based modeling. So we try to add as many events as we can to a timeline and place them into order how they happen on a timeline. So simply, basically, the work starts so that if you, Jose, could think about what are the most pivotal events. The pivotal event meaning that the most meaningful events for the process of wish management, and we could place those ones to the timeline.
Yeah, we need to start describing how like everything happens in order. So I guess the first thing, most important thing is that a kid will have to, or children will have to, or the children will have to make a wish, and I think that'd be the first thing that will happen on this
Yeah,
timeline.
yeah,
Once of course the wish is received um, by the management system, it will probably go to this other service that already handles the tagging or the classification of the wish itself and also of the children, to see whether he's a good kid or whether he's not a kid. And I'm guessing that that's where these child added to naughty list will be or not added to naughty list. Depending on that, if he's a good kid, it is most likely that this wish will be queued into this management system, um, and uh, and then the request will be sent to this other system that we were discussing earlier that handles the building or the fulfillment of the present or the wish. Follow to that. Um, in that system, it can happen that the kid may change his mind or not, and if hopefully he will not, then once that wish is completed, or rather, once we get this event of wish fulfilled and it is sent, we can mark the wish as delivered. I think this is a good timeline of the different events. Of course, this is very basic, very like a general overview of the different events. But what do you think, Simo? Is this a good, an okay order? Where would you place these events in the timeline of these happenings?
yeah. I think this is a very good starting point. And usually this is of course very much simplified case, and the optimal case would be that we would have different stakeholders, more of them. Now it's basically me as a facilitator, Jose as a domain expert, and we work together. But in the real life, there would be probably more complicated context and more people involved in this game of mapping these events. And before jumping into these events, I think it's good if we think where to start. It's good to start from the pivotal events. So, and what those can be, they can be some central elements in the process, some really like milestones, or the beginning or the end. So those are good starting points. And like Jose started, I think the wish received, that was the special pivotal event that starts the whole thing. So child makes a wish and the wish gets received. This is something that we definitely want to store into our database. So let's add it there. And we can also check the last one. So I think that the wish is fulfilled when the present is delivered. So we could put that to the end. And this is the similar thing that when we have collectively, as a group work, added these events to the timeline, we should do this kind of go through where we together think maybe there are duplicated events, maybe the terminology is a bit different in these events that are written by different people, and we will remove the duplicates. We will maybe improve the vocabulary to a more concise way. And this is what happens. And we could do this also with the sticky notes live, or then with some digital board like this. But yeah, wish received, and child can be added to a naughty list basically whenever. So we can use this swim line type of timeline. So this can happen wherever. So let's put it kind of as its own swim line. So wish is received. Present may get queued if the wish is if the children hasn't been naughty, and so on. And then when the present is queued, it will be built in some point, it will be delivered in some point, and then the wish will be fulfilled. So this is kind of the happy path, and then there is also this thing that can happen in between. So I think this is a really good starting point for the scalable modeling. And this maybe lets you to take the first step by following this approach. But then what happens next?
Yes, we will now go into the policies.
Yeah.
What are the policies that we need?
Yeah. What policies should exist? And if I do a recap of the policies, how I use the policy, the word policy may be a bit different from some other approaches, but what I basically mean with policies, they are some rules within the system. They actually are a stateless functions, which are defining business rules or other rules that are running the system. So we can briefly jump back to the this picture. So when we have the modeling necessities here on the top, I could go this quickly through. So the ubiquitous language term represent a terminology that is commonly agreed with all stakeholders, which is used in the modeling and in the code. And then when we are doing the modeling, sometimes we discover things that, and we start diving into the details of that thing, but we still need to make the modeling to happen within a given set of time. Let it be, for example, an hour timeline for the modeling. So if we go really into the rabbit hole, we can add hotspot, we can describe the problem and move on within the timeline and come back to that specific hotspot later. So these are really important sticky notes to stay in the timeline and stay in time when doing the modeling. And then all of these components, they are not too many. They are not expressive enough to describe everything that we need to model. So the description, sticky note to add all kinds of special additions to the existing components when needed. And then we have, of course, the primitives, command, which is an intention to do something, event, which is a fact, something was done. This is stored into it is persisted by the system, and a view, ability to see the state of the system. And yeah, then we come to the policies that was mentioned by Jose. So they are stateless functions. They make the system work. And we have, in the scalable modeling, we have defined 5 types of a function or policy. So we have a gatekeepers, command handlers, event handlers, query handlers, and data aggregators. And we don't need to understand these yet. We come to those later, but we basically can just understand that they define the business logic. They are stateless functions. They are also, when we move in the later episodes into the code, we notice that they are very easy to test because they are stateless functions. So policies. Okay, so we can start thinking about the policies also through the why in here. So huge volume of wishes. So we want to have some policies that are limiting the wishes. One of the policy, and now we are actually moving already from the problem domain to the solution domain to storm a bit about the solutions through the policies. So huge volume of wishes, we want to limit those. Do you think do you have any ideas, Jose, what could we do?
Well, I think one of the policies, I don't know if this might already be handled in the other service, is we need to check whether the child behaves or not, whether he's a naughty kid or whether he's a good kid. We also need to stop and think, okay, is this wish possible, or is the nature of the wish that of a good wish or a bad wish?
Yeah.
So I think that's at the very beginning of it all. That's a good thing to check.
Yeah, definitely. I think the children can also do naughty wishes, and we don't want to let the naughty wishes to go through. We don't want them to wish, for example, for a flamethrower or similar things. So that's already a ability to filter out the naughty wishes and also filter out the wishes from naughty children, because there is a policy that the naughty children cannot do wishes.
And it's also the amount of wishes, right? Like,
yeah, right.
We can wish everything in the world, but how much are we allowed to get or to have? That's
true.
Another policy there, I think.
Yeah, some kids may also be a bit greedy, so they may do a lot of wishes, but it's we cannot fulfill all the wishes of a single kid if the amount of wishes is huge. So it's good to maybe put a limitation to the maximum number of wishes. So I think that is a good starting point to define the first policies to kind of start addressing those problems. And here we have a ready-made example where the policies have been added. So we have a policy that the child must not be in the naughty list. And the wishes, they must not be naughty either, no flamethrowers. And each child has maximum of 10 wishes. So these are good to add. We don't yet define what type of policies these are. We can just add these as whatever policies in between into a right place. So basically when the wish is received, we will activate policies, and maybe we will recheck the wish, or if these are not causing anything, we can approve the wish. So it's part of the timeline now. And next, and here I want to also highlight the fact that the order that I'm now presenting may not be the order that you should be doing this. So you are free to do it in which order you like. But I have noticed that I always start with the event, so that's given. Always start with events. They are the things that you want to store into your system. So if you shut down the system, that is the piece that gets persisted. The events, they are the key elements that makes everything enabled. But the next I move into policies, that may be something that you want to as well do, or then you can also go to the terminology. So when we have added the events into the timeline, we can already start checking that what kind of terminology is used in those events. And when different people from different backgrounds are joining the modeling, there is a different kind of terminology is used. So we need to agree on the terminology. And here I have written this very simple terminology that I have received from the events. If we check these through, we can see that there are these keywords. Starting from here, we have a child, we have a naughty list, we have a wish, approval, rejection, receival, you build, delivered, present, fulfillment of the wish. So if we then we should try to model those as a terms, we can add these ubiquitous language sticky notes to represent the terms. And it's also, I have found it helpful to do a relations between these terms to validate them. So we can add child, we can add a wish, we can do an arrow that we can actually convert to a real sentence. So child gives one or more wish. And we can say that sentence to a domain expert. And if the domain expert feels that it is a valid, meaningful sentence, then probably the ubiquitous language is pretty good. Wish is fulfilled via present. Child might get added to a naughty list. So this is a simple ubiquitous language relating to the context of the wish management. And this is something that everybody should agree on, so that we will use these terms then in the modeling and in the implementation. And these must be something that the domain experts feel comfortable of using.
I'm glad that you revisited this part. It's even to my experience, the lack of having this common terminology, this fine domain, it hinders the work a lot of times, and it definitely makes it a bit harder to scale. So
Yeah,
thank you.
yeah, I believe this is probably, at least from my opinion, it's the most important feature or thing in the domain-driven design. And I think it's also the most important thing in the scalable modeling. Well, there are important things like the fast feedback loop, the ubiquitous language, event centricity, but this is one of those highly critical things to agree on the terminology. This helps in the maintainability, and it helps in the solving the right problems. So it's very crucial to get this into an agreement with all stakeholders. All right. Then when we have the ubiquitous language, and these are just the initial drafts, in real life we iterate these, we learn more when we discuss together. But the next thing that we can do, well, I mentioned that this is the ubiquitous language for a context of a wish management, but that wasn't entirely true. So there is a thing called present, and I believe that the wish management doesn't necessarily need to know about the present, because if you remember, Santa already had another system which was managing the
The fulfillment,
building.
yes.
Yeah. So the present actually belongs to another context. It belongs to that services context, and it's not part of the wish management. So we can simplify this whole thing by adding the external system, the present logistics here, which is using the present vocabulary. And we can make it very simple, this picture, so that we can fit the solution to fill the fit into this podcast. So it looks like this now. And then the next thing, now we have events, we have a bit of policies, but the policies, they how can they work if they don't see what is the system state? So we need to think about how to get the data for the policies. How does the child not in naughty list policy work if it doesn't have access to the naughty list? So let's start thinking that where do we get the data from for the system? And in here, I've added the things that are called states. You can call them as views as well or projections, but let's call them as a states now. When the child is added to a naughty list, this is an event that we get from the naughty child management system. We can kind of project that event into wish management state of naughty list, which contains the naughty children. And by feeding this list to the child not in naughty list policy, which is a stateless function, we can make it to know about the naughty list. The same goes with the maximum 10 wishes per child. We can feed it with the child's wishes, and then it will know how many wishes the child has already made. And the same goes with the no naughty wishes. We can feed it with the naughty wish keywords, and then it can filter out the naughty wishes. Just to make the exercise more simple, we just use static list of naughty wishes here, also in the next episode's implementation. So there's no naughty wish management tool present in here, but we just write a simple list of naughty wishes that this should filter. And basically the child's wishes is projected from the wish received events. And now we have a state which is starting to guide us to a direction of spatial modeling, but let's stick in the temporal modeling, the timeline-based modeling still.
Yes, and that should take us to that event, which I didn't thought about that.
Yeah.
But yeah, besides
Cool.
changing their mind on what kind of wish they want, the wish might be canceled for one reason or another. Maybe the kid became naughty, or maybe he doesn't want it anymore.
Yeah. So this is kind of an invention from the modeling that we can help to reduce the waste by creating a system that makes the children able to cancel their wishes. So if they wish a something great toy on November, but its trend goes down in the early December, they may still want to cancel the wish so that the present won't be built for nothing and it will go to a waste. So we can manage the waste by enabling the children to cancel their wishes. And this is, of course, an interesting challenge because what if the wish has, what if the present has already been built when the child cancels the wish? So this brings the distributed nature of the system into game. But this is, in any case, this is a solution event to a waste management when the wishes change over time. And let's add that also to the picture. And this is something that goes to another swim lane because wish can be cancelled immediately after it has been wished. So basically after the wish has been approved, it can be cancelled, but it can also be cancelled anywhere when it's in the present logistics.
At any point in time, yes.
And then we are starting to reach to the last elements that we need in this temporal model. So we need to think about what is causing these events. They may be external systems or they may be actual humans. So we start adding the actors, the users, and we also have the external systems that may cause something to happen. So these blue sticky notes are the commands. So child makes a wish, and the wish gets received, and then we will feed this command make a wish. For example, this wish received event, or the command directly to the policy, depending how we orchestrate this together with the naughty list. So child not in naughty list gets wish received and the naughty list, and based to those 2 bits of information, it can check if the child who gave the wish is on a naughty list, and if it is, we can recheck the wish. Same goes with the naughty wish keywords. We can give the wish received and the naughty wish keywords to a function, the policy, which will verify that the wish doesn't contain any naughty wishes. And if it does, we can recheck the wish, and we can also consider adding the child to a naughty list. But actually, I think that we could move this one as a food for the naughty list, because the naughty list is populated from an external event child added to a naughty list. And these are the 2 options that are causing when the wish received together with the system state is added to a policy, and the policy will emit either one of those events. And if the wish is approved, the present logistics gets the notion, and at some point the present is delivered, so we subscribe the present delivered external event, which is converted to a mark wish fulfilled, and that will emit the wish fulfilled. And then also we added one query. So for the child to be able to cancel the wishes, the child needs to be able to see what wishes the child has. So there's one query that helps the child to see their wishes and then cancel those. And I want to highlight that there are policies in many places in this picture that are kind of implicit. For example, when the present is delivered, external event is published, we need to have an event handler in here in between that is converting the external event into an internal command. And then there will need to be a command handler that will process this and emit the wish fulfilled event. But it always doesn't make sense to add all of these policies there. We can just only add the ones that are meaningful, that brings the extra value. We can see it from the from this picture, the kind of the rules that if there is a command, we always know that there is a command handler that is processing the command against a state. So the command handler has an access to the command and the state, and then it can emit events if the command is accepted. So we don't need to always explicitly add all the policies into the picture to make the picture to be clear enough. And some of the policies are implicit. But now we are in a point where we will need to move to a spatial representation of this solution idea of these processes. We try to kind of keep the timeline still there, but we need to move things a bit differently so that we can take the space into account. And why we need to do that is that these states of the system, they are the spatial element, like you learned in the last episode. So they need to be connected to a certain space in the world. Like, for example, I have my own state and Jose has his own state, and my state cannot move outside of me. Same goes with Jose. So we need to map these into space, and to remain the consistency of the system, let's say system between me and Jose, we need to exchange information, and it goes over time. Example through events or messages in this case.
Yeah,
But yeah,
it's about this thing like we get the whole idea of the timetable, like the temporal part, in which events may take place at different points in time, but it also means that the state of each system or process, or even the actors in it, is different also. That's the way I think I get this spatial part. It's like we the, we are at different places, and we need to connect the dots of how we get from here to this other place.
yeah,
Which I think you're gonna be doing that now. You're gonna be connecting the dots.
yeah, exactly. And this is that I can say that this is the trickiest part of this whole exercise to demonstrate. I think when you have the right mindset, you understand the need for temporal and spatial. You understand that the need for spatial is due to the basically laws of physics, that you need to distribute things to make them growth ready, to enable their scalability. You cannot have everything on one machine. That's basically the limitation. And when you understand that and you understand the main picture, the rules in this one, that is something that enables you to start building the spatial model out of this. But let's do it in practice, so you can see how it goes.
Yes, and we will continue the spatial modeling in the next episode. There we will take the temporal modeling into a spatial one, and that way make the model ready for the implementation. The next episode should be published 1 week from now, and meanwhile waiting, you can subscribe our LinkedIn channel Scalable Modeling and the YouTube channel also Scalable Modeling. So thank you for watching, and see you in the next episode.